Welcome to Mr. Kritzinger's video lesson based on geometric constructions. In today's lesson we are going to focus on constructing parallelograms. When we are given two sides and an angle in between the two sides, it is possible to construct a unique parallelogram. But first of all, let's revise some of the properties of a parallelogram. First of all, a parallelogram is a quadrilateral. A quadrilateral is a shape where we have four sides and four angles. Next, we know that one of the properties of a parallelogram is that two of the pairs have opposite sides that are parallel. It's not angles, it's opposite sides that are parallel. Let's revise what it means for lines to be parallel. If line AB is parallel to line CD, we use the arrows to indicate that they are parallel, and it means that when we connect AC with a straight line, the point A and the point C, and we connect point B and point D with a straight line, then the length of both these straight lines will be the same. Now that we revised the properties of a parallelogram, let's move on to sketching the specific parallelogram. We are asked to draw or construct rather parallelogram ABCD, where side AB is 4 cm, angle B equals 60 degrees, and side BC equals 6 cm. So we have two sides and the angle in between. For convenience sake, I'm going to start with the longest side, side BC, which is 6 cm. So first of all, I'm going to draw a line that is longer than 6 cm. I'm going to draw a fairly long line. My line is 15 cm. Okay, so now I'm going to move a bit right of the left handmost point, and I'm going to mark it off as point B. Now I use my ruler to measure from point B 6 cm, and we plot point C. So now we know that the distance from B to C is in fact 6 cm. This is exactly what was asked of us. So let's mark off that we meet that condition. Next, we need to draw angle B so that it is 60 degrees. Fortunately, this is revision because we already know from a previous lesson how to draw a 60-degree angle. We need to put the sharp point of our protractor on, or rather compass, on point B. And we need to draw an arc through line BC to the top. Now, without changing the width of our compass, we put it on the intersection of BC and the arc that we have drawn. And we draw an arc to the other side. We are now going to label that arc not label, rather mark that arc. We now proceed to draw a straight line that passes through the point on the arc at point P. So now we have indeed constructed angle B 60 degrees, and we can mark off that we meet the requirement. So next up we need to construct AB as 4 cm. So I will mark off 4 cm on my ruler. That is the width of the compass. So now we will put the sharp point of the compass at point B and make a little arc that crosses the line that we have constructed that passes through point B. Where this arc meets line B, so the line through B, I'm going to plot a point. That point we are going to call A. So now we know that the length of BA is in fact 4 cm. That is exactly what was required of us. So we can mark that condition off as completed. Next, we need to focus on point C. We now need to draw a line through point C that is parallel to line BA. In order to achieve that objective, we are going to have to first drop a line from point C that's perpendicular to the parallel line BA. Fortunately, this is revision of work we already have covered in a previous lesson. So we put the sharp point of our protractor, or compass rather, on point C. Now we need to widen our compass so that we can draw an arc through line BA that crosses on both sides of BA, or the extended BA. Where this arcs cross the extended BA, we can plot points on both sides. Now, without changing the width of our compass, we put the sharp point on the points where the arcs meet extended line BA, and we draw an arc. We change the compass sharp point to the other side where the arc met extended line BA, and we make an arc. Where the two arcs cross, we are going to plot a point. Now we can use our ruler and draw a line through the two arcs, the point where the two arcs cross, and extend that through to point C. As follows. Let's call this line M. So in fact what now happened is that we constructed line M at a perpendicular angle with line BA. Next, what we need to do is to construct a line perpendicular to line M which goes through the point C. Fortunately, this is also a revision of some work that we have done in a previous lesson. We can put the sharp end of our compass on point C and make arcs on both sides. Oops. You just need to be careful. You need to make these arcs in fact on line M. So both sides of C on line M. So there's the first one. Without changing the width of our compass, we make the second one. Where these arcs cross line M, we mark them off with a point. Now we are going to place the sharp point of our compass on these arcs that cross line M. We are going to open the width of our compass so that it extends past line C, the midpoint between these arcs. And we are going to draw an arc on the top and an arc at the bottom. Now we are going to swap around our compass to the other arc that meet line M, and we're going to make arcs on both sides. Where these arcs cross, we are going to mark points. Now in fact we can connect these arcs. And now these two lines should be parallel if drawn accurately. Now we need to do exactly the same with point A. What we need is a parallel line at A to this line BC. So we need a parallel line that goes through A that is parallel to line BC. So we'll follow the same procedure that we followed with C. So first of all, we put the sharp point of our compass on point A. Now we need to widen it enough so that it passes through the parallel line that we are interested in on the opposite side, BC, through both sides. can mark off where this arc crosses the line BC on both sides without changing the width of our compass. We put sharp point where these arcs crosses BC and draw arcs. We change the compass to the other arc that crosses BC and draw an arc where these arcs intersect. We plot the point. Now we can draw a straight line through point A and where these arcs intersect. So in fact, what we have done is we dropped from point A line perpendicular to BC. Let's call this line N. Sorry, let's make it here line N. What we need to do now is to drop, or rather to draw a line perpendicular to line N, which we have just constructed. But that perpendicular line also needs to pass through point A. So we put the sharp point of our compass on point A and make arcs on both sides of line N. So we make it on the one side, we make it on the other side. Where these arcs intersects with line N, we are going to mark off points. Now we are going to put the sharp point of our compass on these arcs where they meet line N, and we are going to make sure that the compass is a bit wider than the midpoint, which is A. We are going to make an arc at the top, and we are going to make an arc at the bottom. We are going to exchange the sharp point to the other point where the arc meets line N. We're going to make an arc on the one side and the arc on the other side. Where the arcs intersect, we are going to plot a point. It seems though these two doesn't cross, so I'm just going to lengthen this one. So now we have the point where indeed they cross. Now we can draw a line through these 2 points. So now where the two lines intersect, we can label that intersection as point D. So now we should have constructed a parallelogram where BC is parallel to AB and AD is parallel to BC. Just going to use a pencil so that these lines can stand, or a pen rather, so that these lines of the parallelogram stands out. Yes, so now we are going to investigate a few more properties. We are first of all going to measure the side of AD. Okay. I get about 5.5 centimeter, but if I sketch this very accurately, I should have obtained 6 centimeter. Because one of the properties of a parallelogram is that the opposite sides are not only parallel but also of equal length. Let's measure CD. It is supposed to be 4 centimeter. Again, I got about 3.5 centimeter. So my sketch wasn't that accurate, but it should in fact be 4 centimeter. You sketch it very accurately. Now next, measure this angle as 60 degrees. Let's measure the opposite angle. Okay, so I'm going to use my protractor. I know it is a sharp angle, so it should be less than 90 degrees. Okay, and I in fact got 70 degrees. Whoops, it should actually be 60 degrees. So you can see my sketch was not that very accurate, my construction. It's partially due to the fact that I have to concentrate a lot in producing the video. So it is not that very accurate. So now let's measure this angle ECD. We know it is an obtuse angle, a fat angle, so it should be more than 90 degrees. In fact, I got about 113 degrees. Okay, if you made your sketch or construction very accurately, you should have actually obtained 120 degrees. So let's move to the opposite angle. Again, we know it is obtuse, so it should be more than 90 degrees. In this particular case, I got about 116 degrees. But once again, if you sketched very accurately, you should have obtained 120 degrees. So Properties of parallelograms are that other than the sides being equal, the opposite angles should also be equal. Now if we add the 60 degrees and the 60 degrees, we get 120 degrees. We add another 120, it's 240, and another 120, it should give us 360 degrees. It is also one of the properties of a parallelogram that all the angles add up to 360 degrees. In fact, that is a property of any quadrilateral, that the four angles should add up to 360 degrees. This will be the marathon session. I trust that your constructions will be somewhat more accurate than mine, as you don't have to focus on recording a video. This is Mr. Kritzinger signing off. Goodbye.